In this video, we're going to solve more at advanced level absolute value inequalities. Now, keep in mind that because the mechanics of solving an absolute value inequality is exactly the same as what we do to solve an absolute value equation, then a lot of what you'll learn in doing practice problems from this video will translate directly to solving different kinds of absolute value equations. Okay, so we start by simplifying the inequality as much as possible. We can't simplify this any further. Now we draw the boundary points. So in this case, we only have these polynomials inside the absolute value. So we just need to solve for where the polynomial equals 0. That's going to be the points where the expression changes from positive to negative. But as I've mentioned, don't worry about that too much, as far as you might be wondering, well, how do I figure out where any expression changes from positive to negative? You'll learn how to do that for any kind of expression in detail in calculus. But if we have a polynomial, we just need to solve. It's going to change from positive to negative wherever it equals 0. So in the case of a linear expression, that's just going to be 1 point. So one x value. So, okay, at x is equal to 3. And at x is equal to 5/2. Okay. So we've got these 3 separate regions here that we need to analyze. So let's start with x is greater than 3. In that case, this is going to be positive or 0, and this is going to be positive. So, okay, we do x minus 3 is greater than 2x minus 5. Let's just solve the inequality. So subtracting 2x from both sides, we get minus x. Adding 3 to both sides, minus 5 plus 3 is minus 2. Multiplying both sides by -1, flip the inequality, x is less than 2. Now, we need to, this is only applicable for these values, so we need to see where do these two, what's the and between these two? Where do these two intervals overlap? X is greater than 3 or x is less than 2. They don't overlap. Okay, so we've done here. Now, what about, let's see, x is less than or well, we just did greater than or equal to 3. That's what I meant to say. Okay, so now we want to do less than 3, greater than or equal to 5/2. In that case, this is going to be 0 or positive. This is going to be negative. So, okay. All right, so minus x plus 3 is greater than 2x minus 5. Subtract 2x from both sides. Subtract 3 from both sides. Divide both sides by -3. You have x, flip the inequality, is less than 8/3. Where does that overlap with this? So 3 times 3 is 9. So this 8/3 is less than 3. So it's going to be, so we're in this region here, it's going to be x is less than 8/3 and greater than or equal to 5/2. Okay, now we just need to do this region. So that would be x is less than 5/2. In that case, this is negative and this is, they're both negative. So we can do, now this is, you know, you might say, well, this is we're solving the same inequality, right? Because both sides are negative, the negatives cancel. But remember, with inequalities, it's a little bit different. So we're just going to go ahead and solve this too. Because yes, we could multiply both sides by -1, but then we would flip the inequality. So, I mean, yeah, let's do that. Multiply both sides by -1. All right, subtract 2x from both sides. Add 3 to both sides. X is greater than 2. So where does that overlap with x is less than 5/2? 5/2 is greater than 2. So that's going to be x is less than 5 halves and greater than 2. Okay, now we just need to apply an or between these two. So x is less than 8/3. So okay, the upper bound is going to be 8/3, and the lower bound is going to be 2. That would be an or between those two, and so that is the solution. You plug any value, any x value between 2 and 8/3 into this inequality here, and it will satisfy it. Okay, we can't simplify this any further. What are the crossover points? We can see we have 4/3 and 2. So there's 2, 4/3. Okay, so we've got 3 regions here. So, okay, let's start with x is greater than or equal to 2. This is going to be, x minus 2 is going to be positive or 0. This is going to be positive. So we've got 3x minus 4 is greater than x minus 2. Subtract x from both sides. Add 4 to both sides. You've got minus 2 plus 4 is going to be 2. Divide both sides by 2. X is greater than 1. Where do these overlap? X is greater than or equal to 2, and x is greater than 1. Well, okay, well, that overlaps here. Just x is greater than or equal to 2. Okay, so let's just put like a note by this. That's the answer. So, okay, now we've got this region. We'll do x is less than 2, and then x is greater than or equal to 4/3. So this is going to be 3x minus 4 is going to be positive or 0. This is going to be negative. So we do like that. So, okay, 3x minus 4 minus x plus 2. Okay, add x to both sides. Add 4 to both sides. Divide both sides by 4. You've got 3 halves. Okay. Where do these overlap? We've got 3 halves is 1.5. So the upper bound is going to be 3 halves. Or no, wait. X is greater than 3 halves. So the lower bound is going to be 3 halves. And the upper bound is going to be 2. 4/3 is less than 3 halves. Yeah, so there we go. All right, that's another answer. So now the last region is x is less than 4/3. Okay, so both are going to be negative. So we've got, and then, okay, let's multiply both sides by -1, and now the inequality flips. Okay, subtract x from both sides, add 4 to both sides. Minus 2 plus 4 is 2. X is less than 1. So x is less than 4/3 and x is less than 1 would be x is less than 1. So now we just need to apply an or here to all of these. So we've got, let's see, we've got 1, we've got 2, and we've got, okay, so 1, 2, and 3 halves. 1, 2, and 3 halves. Okay, so x is greater than or equal to 2. X is less than 1. Okay, and then x is between 3 halves and 2. So it's any real number except nothing between 1 and 3 halves, including the endpoints. So we could put this in interval notation. That would be minus infinity to 1, not including 1, in union with 3 halves to infinity is the solution to this inequality. Okay, let's start by simplifying as much as possible. We see that we can subtract 1 from both sides. Okay, now there's nothing more we can do. So now we just have one absolute value with the linear expression inside of it. So we'll have this one crossover point when x is equal to 3 halves. Okay, let's look at when x is greater than or equal to 3/2. In that case, 2x minus 3 is going to be positive or 0. So we just remove the absolute value. Let's subtract 2x from both sides. X minus 2x is minus x. Let's subtract 2 from both sides. Minus 3 minus 2 is minus 5. Multiply both sides by -1. Flip the inequality. So there we go. Where does x is greater than or equal to 3/2 and x is less than or equal to 5 overlap? Well, that's going to be like this. Okay, now let's do the left side. So, okay. When x is less than 3/2, 2x minus 3 is going to be negative. So we do okay. Now we've got minus 2x plus 3 plus 1. Add 2x to both sides. Okay, subtract 3 from both sides. Divide both sides by 3. Okay, so x is greater than or equal to 1/3, and x is less than 3/2. That's going to be this. All right, now just we need to do an OR between these two. So x is less than or equal to 5. Looks like 5 is going to be the upper point, and then the lower point is going to be 1/3 because 3/2 is a common point. So yeah, greater than or equal to 1/3. That is the solution. Okay, we can't simplify this anymore. So now we've got these two absolute values, and what's inside the absolute values is equal to 0 at x is equal to 9, and at x is equal to minus 12/5. Okay, so we've got these three different regions here. Let's start with x is greater than or equal to 9. This is going to be positive or 0. This is going to be positive. So we've got 5x plus 12 is greater than x minus 9 plus 1. So minus 9 plus 1 is minus 8. Subtract x from both sides. Subtract 12 from both sides. Divide both sides by 4. Okay, where do these two overlap? So x is greater than or equal to 9 and x is greater than minus 5. They're going to overlap here. Any x that's greater than or equal to minus 9 is also greater than minus 5. Okay, let's do this region. So x is less than 9 or greater than or equal to minus 12/5. So this is going to be negative, and this is going to be positive or 0. So we've got 5x plus 12 is greater than minus x minus 9 plus 1. So 5x plus 12 is greater than minus x plus 9 plus 1. 5x plus 12 is greater than minus x plus 10. Add x to both sides. Subtract 12 from both sides. Divide both sides by 6. X is greater than minus 2. All right. So now where do these two regions overlap here? Because these are solutions, but they're only solutions that are within this interval, right? The interval that we specified. So, okay, we've got, so x is less than 9, but then what's more negative? Minus 12/5 or minus 2? Minus 12/5 is more negative, so we'll do, then it needs to be minus 2. So there we go. There's more solutions. So now this region, we've got x is less than minus 12/5. Both absolute values are going to be negative. So okay, we can multiply this entire inequality by -1. Flip the inequality. Okay, 5x plus 12 is less than x minus 9 minus 1. Subtract x from both sides. Subtract 12 from both sides. Minus 10 minus 12 is minus 22. Minus 11 halves. Okay, x is less than minus 11 halves, and x is less than minus 12 halves. Which one's more negative? 5 times 2 is 10. 2 times 5. So this is more negative. So this is going to be the where they overlap. Okay, now let's apply an OR between these three, and to bring all the solutions together into one concise form. So, okay, you've got, okay, so 2 times 5 is 10. So this is around the minus 5 region. Minus 2, 9. So x is greater than or equal to 9. X is less than 9, greater than minus 2. So we've got, in that case, and then x is less than minus 11 halves. So there's a lot of numbers or solutions here. We've got an interval notation minus infinity to minus 11 halves, not including minus 11 halves, in union with minus 2, including minus 2, to infinity. That's the solution set. Okay, and I think I messed something up here. Let's see. What did I do here? 5x plus 12 minus x plus 9, 6x, 12, or 10 minus 12 is minus 2. Okay. So this is minus 1/3. All right, now where do these overlap? In this case, 9 is still the ceiling, and then it's still, okay, it's the same idea. It's going to be minus 1/3 here. So this just changes to minus 1/3 is the idea. So, okay. And also, I don't know why I put a bracket here. It's not including minus 1/3. And then that's the solution. Okay, let's draw the crossover points here. We've got 5/3 and 7 halves. So, okay, 5/3 is like 1 point something. 7 halves is 3 point something. So, okay. Let's start with x is greater than or equal to 7 halves. In that case, this is going to be positive or 0. This is going to be positive, so we just remove the absolute values and solve the inequality. So 3x minus 2x is x. Minus 5 minus 7 is minus 12. Adding 12 to both sides, we get x is greater than or equal to 18. Where do these overlap? X is greater than or equal to 7 halves. X is greater than or equal to 18. They overlap with anything that's greater than or equal to 18. Okay? So now, all right. Next, we've got x is less than 7 halves, and x is greater than or equal to 5/3. In that case, this is going to be positive or 0. This is always going to be negative, so we've got 3x minus 5. Put a minus out front, this becomes plus, and then we could just do 2x minus 7. Right, so I don't want to, I'm doing this. So remove the absolute values by doing that in this case. So what happens is that those two minuses come together, and we're just left with this. So 3x plus 2x is 5x, minus 7 minus 5 is minus 12. 5x is greater than or equal to 6 plus 12 is 18. Okay, where do these two intervals overlap? X is greater than or equal to 18 fifths. And x is, let's see, 5 times 3 is 15. 2 times 3 is 6. So what is, let's use the calculator here. 7 halves is 3 and a half. 18 fifths is 3.6. So 18 fifths is, well, these don't overlap then, right? Anywhere. No. So there's no solution here. Okay. Now we've got x is less than 5/3. So both of these are going to be negative. So let's come over here. 3x minus 5 is going to be negative. 2x minus 7 is going to be negative. So and then just plus 2x minus 7. So minus 3x plus 5 plus 2x minus 7. Minus 3x plus 2x is minus x. 5 minus 7 is minus 2. Adding 2 to both sides, you get, okay, multiply both sides by negative 1. Flip the inequality. X is less than or equal to negative 8. This was we did this for x is less than 5/3. So where do these two overlap? X is less than 5/3. X is less than or equal to minus 8 here. So now we just need to apply an or between these two. X is greater than or equal to 18, or x is less than or equal to minus 8. We just write it as an or statement. You can't really condense it anymore. So x is less than or equal to minus 8, or x is greater than or equal to 18, and that's it. In interval notation, that's going to be minus infinity to minus 8 with a bracket here in union with 18 to infinity. Okay, and I made a mistake here. This needs to be, when I remove the absolute value, I need to put that in parentheses and distribute this minus here. So I don't know what I'm thinking. So, okay. 3x minus 5 minus 2x plus 7. Okay, 3x minus 2x is x. Minus 5 plus 7 is positive 2. X is greater than or equal to 4. And 2 times 3, so this is still, these overlap at x is greater than or equal to 4. So now applying the or criteria here, it would be, this is going to be 4. There we go. Okay, here we have a nested absolute value, but we approach this just like we did with the nested absolute value equations. So we're gonna look at this absolute value of 2x minus 1 and consider where that changes sign. So that's going to be at 1/2. And that's going to be our only boundary point for like the outer problem. So if we start with, okay, if x is greater than or equal to 1/2, so this region, then 2x minus 1 is going to be positive or 0. So we can just remove the absolute value from the 2x around the 2x minus 1. And now we need to solve this inequality, which is also an absolute value inequality. And this is where we're going to account for that outer absolute value. So, okay, 2x plus 2. Okay, let's solve this. Now here we've got the crossover point is going to be at -1. But remember, I mean, we need to keep in mind that we're still restricted to x is greater than or equal to 1/2. So in that case, then, since we're restricted to over here, we know this is going to be positive. And that's the only case. So we just do this. We know 2x plus 2 is going to be positive. So, okay. We're not going to solve the other less than negative 1/2 because that's not even applicable. So subtracting 2 from both sides, dividing both sides by 2. X is less than or equal to 1. Okay, so now, but where do these overlap? They overlap. We can see that x is less than or equal to 1, greater than or equal to 1/2. So these are solutions. You plug in any one of these x values into this absolute value here, and you're going to get, it's going to be a solution. Okay, now let's do x is less than 1/2. In that case, 2x minus 1 is going to be negative, so we do this. Okay, so minus 2x plus 1 plus 3. So minus 2x plus 4. Okay, let's solve this. Where is the crossover point? Here, so that's going to be at positive 2. Okay, but we're only dealing with x is less than 1/2, so we're going to be to the left of this positive 2, which means that anything less than 1/2 is going to make this positive. It's always going to be positive. Like if you put in minus 10, x is equal to minus 10 times minus 2 is 20, positive 20 plus 4 is 24. So okay, so we just remove the absolute value. Okay, now subtract 4 from both sides. Now divide both sides by negative 2. We want to flip the absolute, the inequality. Okay, so x is greater than or equal to 0. Where does that overlap now with x is less than 1/2? That's going to be, so we have x is less than 1/2 and x is greater than or equal to 0. Those are more solutions. Now we just need to do an or between these two. So 1/2 to 1, we can see that's going to be x is less than or equal to 1 and greater than or equal to 0. And that's the solutions. Okay, same idea here. We have this inner absolute value that has a boundary at a crossover point at 2. So we're going to be analyzing these two regions. So when x is greater than or equal to 2, x minus 2 is positive or 0. So we just remove the absolute value. Okay, so minus 2, minus 3. Okay. Now we need to solve this, but let's see. So we've got at x is equal to 5. There's a 0 point, but we're only dealing with x is greater than or equal to 2. But okay, so we're going to have to deal with the crossover point. You see? So let me draw this more clear. You see the difference? So here's 0. Here's 5, where this changes signs. But we're dealing with all numbers greater than or equal to 2. So we have to consider both both the positive and the negative cases. So, okay, first, what about when x is, let's start with x is less than 5. That means this is going to be negative. So, okay, multiply both sides by negative 1, flip this, add 5 to both sides minus 2 plus 5 is 3. X is greater than or equal to 3. So now these overlap between x is less than 5 and x is greater than or equal to 3. But I mean, we're only considering this region. Like that's what we're looking at. This region between 2 and 5. So what we can see is that x is, we just looked at x is less than 5, not equal to 5, and then greater than or equal to 3. 3 is greater than 2. So there we go. These are solutions. But now we have to look at, so, okay, if we're greater than or equal to 5, so x minus 5 is going to be positive, add 5 to both sides. X is less than or equal to 7, so that's just going to be x is less than or equal to 7, greater than or equal to 5. And then we can go ahead and just, right now, let's combine these into an OR, and we'll get 3. There we go. Those are all the solutions that, in terms of x being greater than or equal to 2, right here. Now, what about x is less than 2? So we've got, in that case, we know that x minus 2 is going to be negative. So okay, minus x plus 2 minus 3. Okay, minus x minus 1. Okay, so where does this cross over? This crosses over at -1. Okay, so we're going to have to consider 2 cases again, because we've got 2 here. Any x is less than 2. So we're going to start with, let's start with, if x was 0, we're going to be negative. So let's start with x is greater than -1. That means that minus x minus 1 is going to be negative. So we do this. Okay, so let's distribute the minus. Subtract 1 from both sides. X is less than or equal to 1. So we can see it's like all of this is going to be the solutions. So x is less than or equal to 1 and greater than -1. Okay, now what about x is less than or equal to -1? In that case, minus x minus 1 is positive or 0. So we just remove the absolute value, add 1 to both sides, multiply both sides by -1. X is greater than or equal to -3. So that's going to be, we can see, will come all the way, that will come all the way back to, we'll do this. Now combining these in an OR, we get -3, and then, yeah, so there's the solutions when x is less than 2. So we've accounted for x is greater than or equal to 2, x is less than 2, so that's everything. So now let's just combine these two as an OR. So -3 to, yeah, it looks like it's going to be -3 to 1 and then 3 to 7. So -3 to 1, well, with brackets. So -3 to 1, and then in union with 3 to 7. That's the solutions. Okay, we can't simplify this anymore, so let's find all of the crossover points for this quadratic expression here. So with a polynomial, it's just going to be where the polynomial equals 0. So let's see. X squared plus 3x minus 4 is equal to 0. Let's solve this. So we've got x, 4, 1. We could do plus 4 minus 1. So x is equal to -4 and x is equal to 1 is where this expression can change signs. These are the only 2 points where this expression can change signs. And again, don't worry if you're wondering, well, how do we figure out where exactly an expression can change? Any expression can change signs. You'll learn that in extreme detail in calculus. But that's the idea. We're trying to mark off all of the points where any of the expressions inside of any of the absolute values in the entire equation can change signs from positive to negative, negative to positive. That's what we're trying to mark off here. Okay, so in this case, we've got 1 and -4. So we've got these 3 regions here. Okay, so now we want to analyze the equation or the inequality in these different regions. So, okay, this is 1. So, okay, let's start with x is, let's see, greater than or equal to 1. So that would be if x is 1, you get 4 minus 4 is 0. Then if x is 2, let's see, you get 4 plus 6. It's positive. So, okay, this is going to be, when x is greater than or equal to 1, this is going to be positive or 0. So we just remove the absolute value. Okay, and now we solve this inequality. And remember, how do you solve any inequality? Like in complete general. Well, when it came to the linear inequalities, we could do it with the whole shortcut method, where you just kind of solve it with the adding, subtracting to both sides, etc. But in general, you can't do that. In general, you're going to have to bring everything to one side. So subtract 6 from both sides. Get this. And then now we need to analyze this expression for all the regions where it's positive or negative. And then we can read off from that analysis, okay, where is it less than or equal to 0, and write those intervals out. So, okay, where is x squared plus 3x minus 10 equal to 0? So let's solve for when this quadratic is equal to 0. So we've got 5, 2 plus 5 minus 2. X is equal to negative 5, and x is equal to 2. Okay, so now we just want to, we know that a polynomial can only change signs when it crosses through 0. So we just need to analyze, we're trying to see where this is positive and negative. So if we plug in, for example, plug in 0, that's between minus 5 and 2. You get negative 10. So we know it's going to be negative in this region, and it won't change signs unless it goes through 0. So only crossing over these two spots. Now, again, I'm going to keep saying this. If you feel uncomfortable on how to look at any kind of expression and analyze all the different intervals and regions where it's positive and negative, don't worry about it. Don't worry about it. Just try and get used to the mechanics of what we're doing here. By the end of calculus, you'll be an expert at that with any kind of equation, at analyzing the intervals of where it's positive, negative, etc. So, okay, now let's plug in minus 6. So something over here to the left of minus 5. So minus 6, you have minus 6 squared is 36. Minus 6 times 3 is 18. So we've got 36 minus 28. That's positive. Okay. So it's positive here. Now let's plug in something over here. So what about 3? 9 plus 9 minus 10. 18 minus 10. That's positive. Okay. And it's equal to 0 at minus 5 and 2. So now we can see, when is this less than or equal to 0? Well, it's going to be when x is less than or equal to 2 or greater than or equal to minus 5. Okay, but now where does this overlap? We're only analyzing when x is greater than or equal to negative or greater than or equal to 1, right? So where do those two intervals overlap? Well, that's going to be when x is less than or equal to 2 and greater than or equal to 1. So there we go. Now we need to do when x is, let's say, less than 1 and greater than or equal to negative 4. So if x is 0, what's inside is negative. And so we know that this is, let's see, this is going to be when x is 1, we've got, this is, so yeah, let's do this. Because when x is negative 4, it's also 0. When x is 1 or negative 4, this is 0. So let's do, when x is between minus 4 and 1, this is always negative. So we've got, we simplify, we just remove the absolute value and put a negative out front. Now we can multiply both sides by negative 1. Flip the inequality. Now let's add 6 to both sides. Minus 4 plus 6 is positive 2. And okay. So now let me just use the calculator here. This will be quicker. when is x squared plus 3x plus 2 equal to 0? We're solving for x. When x is negative 2 or x is negative 1. Okay, so x is negative 2, x is negative 1. Okay, if we plug in 0, we see it's positive over here. If we plug in negative 3, we see we've got 9 minus 9 plus 2. It's going to be positive over here. Okay, now let's plug in minus 3 halves. That would be right in the middle here. So minus 3 halves squared is going to be 9 fourths. And then 3 times minus 3 halves is minus 9 halves plus 2. So 9 fourths minus 18 fourths plus 8 fourths. 9 minus 18 is minus 9 plus 8. So this is going to be negative. Okay, so now where is this greater than or equal to 0? Well, we can see that's going to be when x is less than or equal to minus 2, or when x is greater than or equal to minus 1. Okay, but now where do these two overlap? So this is kind of confusing. Let's draw this out. So we've got, let's see, 0, 1, minus 4, minus 2, minus 1. Okay, so we've got between minus 4 and 1, without including the endpoints. Okay, now x can be less than or equal to minus 2, and there's solutions, or x can be greater than or equal to minus 1, so there's solutions. This is an or criteria. We don't need to have all three of these at the same time. It's this or this and then this. So it's or that. Okay, now the last thing we need to do is x is less than minus 4. Okay, but if we think about it, so what's going to happen when x is less than minus 4? What happens? This is going to be positive again. This is going to be positive, this expression. So, but that doesn't mean that we can just ignore this. It just means we don't have to solve the equation again. We already did the case where we just removed the absolute values and solved. The result was what? Was this. But the difference here is that we originally compared this, we took the and between these two. For x is, now we want to take the and between these two. So where does the crossover between x is less than negative 4 and x is between minus 5 and 2 inclusive? That's going to be x is less than negative 4 greater than or equal to negative 5. So there's our three answers. Now we just want to combine those with an or. Okay? So let's see. We've got 1, 2, minus 4, minus 2, minus 1, 1. We got a bunch of numbers here. So let's see. 0, 1, 2. We go all the way down to minus 5. We've got a minus 1. We've got a minus 2, a minus 4. That should be it. Okay, so we've got, let's see, 1 to 2, including the endpoints. We've got minus 5 to minus 4, including the endpoints. We've got minus 4 to minus 2, including the endpoints, so we could go all the way here. Then we got minus 1 to 1. So, okay, we could do we've got this. -5 to -2, and then -1 to 2. That's the answer. So x, we've got including -5 all the way to -2, including -2, in union with -1 to 2.